flipped it, bro. We flipped it.
So we are still on section 5.1. Label it as simplifying. A trig function.
Trig.
And I'm going to start off right away with an example. And the example is that if you have the sine of x times the cosine squared of x minus the sine of x, our job is to try to get this simplified. I'm going to tell you what your end result should be. You should end up with a negative sine of x cubed.
Is that supposed to say minus sine x?
Minus the sine of x, yes. All right. Do you know what I'm talking about now? The part about not really loving this stuff very much. Do you remember?
No.
These are the identities, yep. And what our job is to do is to try to get one side of the function equal to the other side, or one side of the equation equal to the other side. So in what I have always told you guys to do is to take the side that looks more horrible and try to get it to look like the other side. So don't start with negative sine cubed of x and try to get it to look like the other side. Start with the left side and try to get it to look like the right side.
Oh.
So, open up your minds, think about all the math that you've learned over the years. Remember that if you attempt something one way, it might not work, and you might have to start over and do something else, okay? In fact, I do these, and I try one way, it doesn't work, I mean, it just happens. You just don't know which direction you need to head in. So what do you recognize about the left side of the equal sign? What could you do with this?
Change the cosine.
Change it to cosine.
Change that cosine so you have another sign.
It's just cosine can't be written in terms of sine.
Oh yeah, that makes sense.
But look at these two terms. We have this going on and we have that going on. What do they have in common?
Two signs.
They both have a sine of an x. So try factoring the sine of x out. So take a sine of x out. If I divide a sine of x out of the sine of x cosine squared of x, what do you have left?
Cosine
I
squared
take a
x.
sine of x on this. I'm going to have a cosine squared of x. What did you just say? Cosine squared of x minus 1. Yeah. Yep. Minus 1. Do you see what I just did?
Oh, okay.
Both of these terms, this right here and this right here, have a sine of x in common. So you factor a sine of x out. Just like, for example, if you had this. If you had 3x squared minus 2x, what could you factor out of that? What do they have in common? They both have at least an x. So I could take an x out. That's what I'm doing.
Yeah.
What do these things have in common? They both have an x in common, or a sine of x in common. So you take a sine of x out. So you take it out. It leaves you with this. And then if you divide a sine of x out of a sine of x, what are you left with? You're left with a 1. All right, now this should look familiar to you. What is the cosine squared of x minus 1? Careful. You have the sine squared of x plus the cosine squared of x. You get 1, right?
Yeah.
Okay. So cosine. So if I were to take the cosine squared and subtract it on the other side, I would have 1 minus the cosine squared of x, right? Which would be the sine squared of x. But this does not say 1 minus the cosine squared of x. It says the cosine squared of x minus 1. So it's backwards. So it's not sine squared of x. It's going to be negative sine squared of x. So this is the sine of x times the negative sine squared of x. Be careful with how this is written. This does not say 1 minus the cosine squared of x. It's written backwards. So it's the opposite of having the sine squared of x. All right. What is the sine of multiplied, this is not this minus the sine squared of x, it is the sine of x times the negative sine squared of x, which is negative sine cubed of x.
Okay.
That's what you need to do.
The burn already hurts.
I feel like
There's
I'm
only
serious
one
right
part
now.
I didn't get.
I collect more knowledge when I say things. Oh, it's because I have the book in front of me.
Yeah, that's the part I
Like,
didn't
you
get.
take out a sign and all those, because they have, like, each, like, they have a sign in them.
The one below
Not
it.
that one.
This one right here?
Oh, because cosine is where x is, this is backwards, like, you equals
So are you not sure where I got this?
Yeah.
It's because
So-
it's not one by one.
Let's go to, I'm gonna write, we have sine squared of, we know this identity, you guys are comfortable with this one, right?
Yeah.
And we have written this thing a couple of different ways. We have said that the sine squared of x is equal to 1 minus the cosine squared of x. Right? We've also said that the cosine squared of x is equal to 1
Close
minus the sine squared of x. Yep. But that's not what we had in this problem. We had the cosine squared of x minus 1. So we have this, but it's backwards. Okay? So in other words, if I were to multiply this by a negative 1, then this right here would become a negative 1, and this would become a positive cosine squared of x. But if I multiply this side by negative 1, this side has to be multiplied by negative 1 also. So we have negative 1 sine squared of x is equal to, this is the same thing as the cosine squared of x minus 1. Okay, so just be careful what order they're in. But it's written in the opposite order, so it's not going to be a positive sine squared, it's going to be a negative sine squared. Alright, let's do another example. I have 3 examples total for those of you that are like, how long is she going to talk today? 3 examples. Alright, sine of x plus the, by the way, in your assignments, if they ever give you thetas or t's or whatever, you can always use x's. I don't care if you switch them. It's just so much easier. It's what you guys are used to writing, so much easier to write like that. I would like you to make this equal to the cosecant. So it's a puzzle. Think of it like a puzzle. Don't you guys love doing puzzles?
No.
No, not
I
really.
love doing puzzles. I do.
I like Rubik's cubes.
All right. What can we do? Are we gonna change things around on the left to make it match the right,
Yeah.
or change things around on the right to make it match the left?
Let's change the right.
Let's change the left. Great idea, Michael. What can I do?
Change
The inverse.
change the left.
I like how you're thinking. She said make this cotan 1 over tan. But let's not do
And
that.
if we make sine 1 over sine.
We have a sine, we have cosine, right?
We get cosine.
Can't you write cotan as sine and cosine?
Yeah.
Right? Let's do that. So I'm gonna keep the sine aside.
What do I do?
Plus, how can I write cotan? You can write it as cosine over the sine. But it's still, we still have a cosine here. So it's cosine over sine times the cosine.
Cotangent is cosine.
Remember, tan is sine over cosine. So cotan is just the reciprocal, cosine over sine. Don't forget that. That's like one of those things where you should be thinking like that all the time. All right, one more step. Not one more step, more than one more step, but let's clean this up one more little bit. If you have the cosine over the sine and you're multiplying it by the cosine of x, that's like multiplying by the cosine of x over 1. You're multiplying fractions. What is the cosine times the cosine?
Cosine squared.
Cosine squared of x divided by, what is the sine of x times 1?
Sine
The sine of x. We have the sine of x. All right, now,
See where this is going.
this is here, we're almost done, but when you are in a situation like this where you have a fraction, or maybe you even have two fractions and they don't have the same denominator, remember this sine of x is the same thing over the sine of x over 1. You need to start thinking about back in middle school when you learned how to add fractions. And the way that I showed you guys, or reminded you of how to multiply fractions, you had to, I want you guys to cross multiply. Do you remember this?
You didn't teach us.
Well, I said when I reminded you by teaching you to cross multiply.
Okay.
You multiply this way. Sine times sine is
Sine squared.
sine squared. And you multiply this way, which is 1 times the cosine squared. So we have plus the cosine squared of x. All divided by, and then what did we come up with? How did we get the denominator?
Multiply the denominator.
How many denominator? 1 times 1. Yeah, you multiply these two denominators. You multiply the two denominators. So you multiply left to right. You multiply left to right. And then you multiply the denominator. So you multiply this way, you multiply this way, and then you multiply the two denominators. So you're going to end up with the sine of x on the bottom. All right, you should notice this right away. Sine squared plus cosine squared, what is it?
1.
1. So really what you have is 1 over the sine of x. You're done. What is 1 over the sine of x? It's cosecant. So you had to think a couple of things. You had to cotangent. You had to know what's cosine over sine. You had to cross multiply because you had two fractions that you were adding together that had different denominators. And everything else kind of fell into place. All right, one more example and then I'm going to stop. Secant of x minus the tangent of x times the cosecant of x plus 1. What do you think when, oh by the way, we want this to be cotangent. What do you see? What, you see multiplication. More, I want more than that. What kind of multiplication? What method are we going to use?
Foil.
Foil, very good. Yeah. It's a binomial times a binomial, so FOIL. So we're going to multiply secant of x times the cosecant of x. And let's just, it's going to be long, because there's a lot of writing here, so don't write huge. So we have the secant of x, cosecant of x. And then we're going to multiply secant of x times 1. So we have plus the secant of x. And then we're going to multiply negative tan of x times the cosecant of x, which is negative tan x cosecant of x. And then we're going to multiply negative tan of x times 1, which is negative tan of x. Now we've got secants, we've got cosecants, we have a tan. Do we have a cotant? We don't have a cotant, but we want to think about it in terms of cotant. So my suggestion right now would be to start writing these things in terms of sines and cosines. How can you write secant in terms of sine and cosine? Sine or cosine. 1 over the cosine. So we have 1 over the cosine of x times cosecant. 1 over sine. Plus secant is what? 1 over cosine. Minus sine over cosine. Very nice. Sine of x over the cosine of x times, what about cosecant? 1 over sine minus sine over cosine.
Oh my gosh.
That's ridiculous.
I quit.
It's fun.
Oh my god.
Okay, let's start canceling things out.
Okay.
Can you see anything that can be canceled out right now?
Signs.
Very nice. These two things right here, these are being multiplied. You have a sign on the bottom and a sign on the top. Get rid of them. What'd you say? Yeah, you have a 1. But look at it. You have a 1 over a cosine left with a minus sign in front of it. And right before it, you have a 1 over cosine. So you have a 1 over cosine minus 1 over cosine. So what's going to happen to them? You're going to cancel right out.
Oh my gosh.
This is how it works.
Isn't this great?
No. That's too much.
Yeah, I'm reading.
All right, let's 1 time, we have a fraction times a fraction here. 1 times 1 is 1. Cosine of x times the sine of x is the cosine of x sine of x minus the sine of x over the cosine of x. Okay, what do you have here? I was thinking more like, oh, it's a fraction minus a fraction. Yes.
How'd you get the 1 over cosine x times?
Times the 2 in the
Multiply
front.
together.
These two right here are multiplying. 1 times, we're multiplying them, so you can just go numerator times numerator, denominator times denominator.
Oh.
Okay, so 1 times 1 is 1 over the cosine of x minus the sine of x, or cosine of x times sine of x. This showed up in the last problem. You had I think we were adding fractions in the last one. This time we are subtracting them, but they have different denominators. Do you see that? You're going to cross multiply, yeah. So you multiply this way first. 1 times the cosine of x. What's 1 times the cosine of x? Cosine of x. Then you multiply this way.
Negative
Squared of x.
cosine sine squared.
Very good.
Or not.
I'll do sine squared of x cosine of x. Are you okay with that? Why is there a minus sign in between these?
Minus sign in the middle.
Yeah, because I'm subtracting them, yeah. And when I multiply the cosine of x times the sine of x, we have 2 sines, making it sine squared, and we only have 1 cosine, so it's cosine. Okay, what am I going to end up with on the bottom?
Cosine squared of x sine x.
Cosine squared of x, sine of x. Right on?
Right on.
This has everything all thrown at you at one time.
It's too much.
Okay, look at the numerator. Think back to the first problem. What did we do in the first problem?
Moved a lot of stuff.
The very first thing we did was we what? We factored something out, right? We factor out a sine of x? What are you going to factor out here?
Cosine.
You're going to factor out a cosine. So factor a cosine of x out of the numerator. If I factor out a cosine of x here, what do I have left when I factor a cosine of x out of a cosine of x?
Negative
1.
Wait, what?
Isn't it just
Which cosine x are we taking out?
I took a cosine of x out of each one of the terms in the numerator.
I have a question.
Okay.
Oh, okay.
How did you get the denominator? I know you got the numerator.
The denominator I got by multiplying the
Denominator.
cosine of x sine of x times the cosine of x. I multiplied the denominators. So cosine of x times the cosine of x is the cosine squared of x sine of x.
So you got the numerator by cross multiplying, and then you times the denominators at the bottom.
Yep. All right, so when I factor a cosine of x out of the 2 terms in the top, when I factor a cosine of x out of this, I'm left with a 1 minus.
Yeah. Huh? Minus sine squared.
Okay, let me take it. Okay, let's say we had this. What if we had x minus 9x? What if that That's what it was. It was not this sine and cosine stuff. What do these things have in common? They have an x in common, right? So you take an x out. So if you divide an x out of this x right here, you have 1 left. If you divide an x out of this, those cancel out. You're left with 1 minus 9.
Why did you do that in the first one?
I did do that in the first problem. The first problem, I took a sine out. Yeah, and I was left with cosine squared minus 1. I'm gonna flip back. To the first screen. We took a sine of x out. So in other words, this is what I did. I divided a sine of x out here, and they canceled out.
This
And-
is because it's minus, not prime?
There's a minus here.
No, I thought this one of my ideas.
And then I divided sine x out. When those cancel, I'll leave me with just 1. So here, I'm taking out a cosine. It leaves me with a 1, and then a minus, and then we have a sine squared of x. Divided by the cosine squared of x, sine of x. What is 1 minus the sine squared of x? Cosine squared. Right? So this is the cosine of x. 1 minus sine squared is cosine squared of x. Divided by cosine squared. Sine of x. What can I cancel out?
The cosine squared of x, and you get cosine.
You're left with a cosine on top, a sine on the bottom, which is equivalent to yes.
Why we factored out cosine on the top? I thought we were factoring out on the bottom. Why didn't we factor one out on the bottom? Because I didn't have it in 2 separate places.
Well, are you don't just because you factor out in the numerator doesn't mean you have to factor it out in the denominator. It's because what I have done when I'm looking at this numerator, by factoring a cosine of x out, I am not changing the value of the numerator. You know what I mean? I'm just rewriting it.
So I didn't, like if I factored it out, would it still come out to the same thing?
Yeah, you certainly could have, and then this cosine of x that you have out front right here, and the numerator would have factored or would have canceled out with one of the cosines in the bottom, so you would have just had less to deal with. But I don't know that it would save you time. All right. Anything else you wanna? I know these are not, the most amazing part of your life or anything like that. But anything you wanna say before I turn this off?